Hi guys. Okay, so this first short video is just going over the reaction types from the notes on section 2, all right, of chapter 6. Okay, yeah, we went over on Wednesday section 1 a little bit and just kind of introduced a little bit of the initial reactions and reactants and products and what the arrow meant, and everything on the left of the arrow is the results of the reaction, and everything we have on the left we have the same on the right, so it's called so we're talking about balanced equations. So I just want to run through this real quick what this means. There's basically a handful of types of reaction we have. The first one is what they call synthesis reaction. So they use the letters A, B, and remember the arrow represents a reaction, like an equal sign, okay? So remember you have your reactants and then the products, the R and the P as I described it. So this is what's combined. So this is substance A, reacts with substance B, and in the presence of the reaction they become AB, okay? So this is what they call synthesis, or adding things together. Synthesis is the same as bringing something together, okay? So I'm just summarizing these simple slides on 5 basic definitions and visually be able to see what the formulas would look like, okay? So here's an example. If I had sodium, Na, and I put it in the presence of chlorine, Cl2, right? So basically when I bring these two together and I balance out the equation, I got NaCl. So because we always know chlorine, all right, pairs with a partner molecule, right? So this is in why they balanced it. And that's the 2 parts that we're going to do. A, recognizing the type of reactions that we have, and B, balancing the equation. Remember what we have on the left, we got to have on the right. So this is example of AB. They put it in red. Sodium's your A, chlorine's your B. It could have been vice versa. And now I combine them AB. That's why you put the 2 here, because I had Cl. There's 2 Cl's here, so I got to have 2 Cl's here. So they put a 2 here. So that made 2 times 1 is Cl. So now that gave me 2 sodium, so that's why I had to put a 2 there. So it's balanced, okay? So this first reaction is basically like addition. This is synthesis, okay? All right, that was the little videos, because these are older and the computer's compatible, explaining what I just did, and they won't play, okay? The next one is decomp, which is kind of like the opposite, because decomposition is the breaking down, decomposing, deteriorating, whatever words you want to think of. So this is real similar. So it's the opposite of synthesis. So we have AB together, and then in the present reaction, something separates it. All right. So for example, here's water. Okay. So if we had water, H2O, and through hydrolysis, or it's irrelevant, but whatever was, something was able to separate the hydrogen from the oxygen, then you have A plus B. Because there's the A. They even color code them on the slides to help show you what they mean. All right. So real simple there, because then I have 2 H's, okay? And oxygen is always paired up by itself. Now the good thing about that is, all you have to do is balance it. So when you saw this, you're like, oh, it started together, separated, oh, that's decomposition. Then if I had to balance it, well, if I had 2 O's here, okay, and 1 here, so when I put a 2 here, 2 times 1, that works. But then that made 2 times 2, because the subscript, remember, you times it, because this is like the whole molecule, 4. So that's why I had to put a 2 here. 2 times 2 is 4. So 4 H's, 4 H's. 2 times 1, 2 O's, 2 O's. Done. So remember, decomposition is the opposite of synthesis. I'm taking something and pulling it apart. Synthesis is taking 2 things and putting it together. All right, 2 down, 3 to go.
Decomposition reaction. A decomposition reaction is a chemical change in which a single compound breaks down to form 2 or more simpler substances. Passing an electric current through water, for example, causes the water to break down into the elements hydrogen and oxygen.
Okay. All right. Third reaction is what they call combustion. Now this is even easier because it's in the presence of oxygen. Okay. Now remember my crazy example on Wednesday about a car engine. And when you put oxygen, it reacts with it, separates it out. You see water drip out of the tailpipe, carbon monoxide. Okay. We talked about oxygen going in, fueling the combustion reaction. So basically, all you got to know about the third reaction is combustion reacts using oxygen as its reactant. So it's like adding air to a fire, having an air filter pump into an engine, whatever it might be. Okay. So in combustion, the products depends on the amount of oxygen available. So that's why I use that example of those old cool muscle cars that had the big blowers on the front that had those little valves that flop. Okay, the more air it could suck into, the quicker and more powerful the combustion reaction, I get more horsepower and turn that crankshaft. Do you remember my example with that? Okay. So that's the easy one there. So it's all about the amount of oxygen present in order to how well this combustion reaction works. Okay. So you're just going to look for oxygen present. Okay. All right. All right. So single displacement. Now single displacement and double displacement are the last two. All right. So you notice how you have element A and element B added up here, and notice they leave it as X. Okay. So this is like a third compound. All right. Present. Okay. And when they go through the reaction, the term displacement means to switch. Okay. Always like to remember that term when they talk displace. It means like moving from one place to another. It's just like a switch. It's just a word. You don't use it that much, but to displace something is to place it somewhere else. Okay. So you see, you got A and B. So you notice that basically they're just switching, and it was a single displacement. So when they went on the other side, B switched with A, and A became the single component out. Okay. So you see here you have copper paired with chlorine added to aluminum. Okay. So when they went through the reaction, like I said there in this particular case, they just switched the single compound by itself, replaced it. Okay. All right. And the copper, okay, was removed out. Okay. Yep. So they just replaced that. So when you see that one that was there before in this particular case, copper, right, and this thing and moved out, a single displacement. Okay. So just one of them got flip-flopped out. So they're pretty easy to recognize. And like I said, all you have to be able to do is look at the example I ever give you and say, oh, is that? Tell me what the reaction is. It's kind of like a vocab test or a matching test. Okay. But knowing what type of reaction you're having also kind of tells you what's going on. Okay. And the last but not least, really quick to the point, is what they call a double displacement. Okay. Right. So a little more busy stuff going on here, but now I have A, X, and Y present. All right. So basically, you're displacing two things. All right. So in this particular case, the A and Y matched up, and B and X. So you switched to two formulas. So you see here, I have lead and NO3. There's a polyatomic ion nitrate. Okay. And I have potassium with, I think that's permanganate. I think I have to look at my polyatomic ion sheets too. But then when they went through reaction, the lead then paired up with the reds paired up, and then this switched with that, so that it's basically a double placement. Unlike the single displacement, one thing switched. This, they just switched partners on this particular case. So you notice when you look at the initial reactants and the products, you see, oh, these two were together and these two together. Now they flip-flop. Oh, so two things switch, so I have a double displacement. Two things switch, okay? So I summarized that and just kind of watered it down because I realized sometimes, even those are good examples, but the wording is a little different than how we may be simple to explain, okay? So that was section 2 on reaction types. Real simple, real straightforward. I think you might have gotten past that part already on your reading guide on Tuesday, I believe. Yeah, on Tuesday, Wednesday, okay?
Double displacement reaction. In double displacement reaction.
And you can play this little video for the example, listen to it. I believe that will show up because it's showing up on mine. It's the other examples that do not. Okay, section 2, all right. All right, so this is just explaining another what they talk about oxidation reduction reaction, any chemical change in which one species gains electrons. Okay, we'll talk a little more about that, but more importantly, I wanted to make sure that you understood, so that last little slide. But the biggest thing is we want to find is those 5 types of reactions. Synthesis, which is like adding some A plus B gives you AB. Decomposition, once you have AB together, they go through reaction and separate them into A and B. Combustion is just, all you gotta do is look for the presence of O2. So you have this fancy formula plus O2. As soon as you see that oxygen out there, oh, it has to be combustion in the product. You'll see it in there. And then single displacement is one thing switches when it goes the other side, and double displacement, two things switch, okay? All right, so this is video 1, and this is the video lecture on section 2 of chapter 6, okay? All right, so I'm gonna stop it here, upload that one separate, and then the next one I'll make is section 3, which is balancing equations.